I'm excited today to talk about how DevOps can be can free your team from painful and disruptive deployments. Um, there's so much information out there, but it's information overload, and there is a way that a DevOps process needs to be organized in order to yield the results that we're looking for. And so the material for today is targeted towards executive team managers, architects, team leads, essentially anybody who is responsible for a development team, whether you're the lead developer or the architect or supervisory level, or whether you're in a company and you're the chief operating officer and the development department reports to you. If you are leading a development team, then this content is for you. And as such, we're going to be really targeted, really quick, and we're going to get you out of here as quick as possible so that you can ingest the information and then come back. We're going to follow up this webinar in the new year with more technical, in-depth implementation about how you actually put all these pieces together on the Microsoft platform with those technologies and how they fit together on a technical walkthrough. But today's session is going to be all about the strategy for guiding your team to implement DevOps and free yourself from those painful and disruptive deployments, and so that you can really run your software with confidence. So let's go ahead and dig in, and please feel free to ask questions in the Q&A panel and also in the chat window. Ask questions and I'll answer those in line. And don't worry, if there's any colleagues who wanted to be here, we are recording this content and we will be emailing out a link to the recording to the attendees so that you can share it with your colleagues and friends. So let's jump into it a little bit about us and about me. I'm Jeffrey Palermo. I'm the chief architect of ClearMeasure, and we are a DevOps-centered software engineering company. And our goal in software is to help software teams move fast, build smart, and run with confidence. And this DevOps certainly does that when implemented well. Now, basically, let's get this out of the way. Here's our elevator pitch. You can read it. We're a DevOps-centered software engineering company that specializes in Microsoft and cloud platforms, and we can help you create a well-run software factory to better connect with your customers. It will enable you to move fast, build smart, and run with confidence as a team and as a business. You have a development team, and we want that team to be world-class. If you don't have one and you need a team, we build those and operate them for you. So those are the two practices in our business, and that's why this topic is just so energizing for us. Our vision for you is to be world-class at serving your customers through your software. We want you to be world-class. We want every development team on the planet to be awesome. And DevOps, when implemented properly, is a big step forward in lead time improvement, cycle time improvement, shipping things to market, reducing defects, and ultimately having happy customers operating the software well. Let's move through what it takes and what our context is. So in our world, your software connects you with your customers. More and more, 10, 20 years ago, there were decision support systems where internally the people use software, but ultimately the people connected with the customers. More things are online. The software itself is connecting with the customers, and you expect to be able to use software in the receiving of services from companies that you purchase from. So that's just the way it is in today's day and age. Common challenges across all of our clients, and I'm sure some of those resonate with you, are the pace of delivery and quality of the software. And some of you may have a software system that kind of looks like this ball of rubber bands. You're constantly asking, why is it so painful? What's this change going to impact? Things like that. So here is our model for what it means to have DevOps-centered software engineering. And we're going to walk through this model because each of these is important. Okay. Now, the software challenges that this DevOps model tackles is your businesses is growing at a demanding pace. The software is increasingly critical to operations. It's getting more complex. It's prone to errors, or maybe the software or an environment is dependent upon key talent. Maybe there's one person on your team that struggles to take a vacation because they do a particular thing and they can't free themselves. If they go away, something bad happens. And also painful disruptive deployments. We want deployments to be so easy. And the DevOps process, implemented properly, it gives us that. Okay. So the value, the things on the right, very little to no downtime, happier customers, more bandwidth for the development team to deliver features. That is so huge. There's so much, if you ask your developers, how much time are you able to focus 100% on building the next feature in the software versus maintaining it, supporting it, checking on the environments, deploying new versions of software? Their day just gets sucked up in many times. So that's the model. Now, we focus on 3 themes for this model: moving fast, and building smart, and running with confidence. And so in DevOps, the imagery is this development software factory where you have an assembly line where features, ideas move through this process, where much of the mechanics is automated. And the idea moves through and comes out the other end as working software that's in an environment where the customers are using. So we use this factory metaphor because in a factory, you have a sequence of workstations, and each workstation has raw ingredients and it moves work product to the next station. Your swim lanes on a Kanban board, or if you use swim lanes in a Scrum process, that's the process. That's the assembly line where you're linking together these workstations and things move through. And what DevOps allows is the removal of bottlenecks and the automation of all the mundane tasks so that those things can flow really quickly. Building smart is all about making it continuous, focusing on productivity, and you need the right skills, the right architecture, the right methods in order to do that well. You want to run your software with confidence. You don't want downtime. You don't want to have big deployment maintenance windows where you have to take down the software. And so you need to move along the right features. You want the right cadence and the right quality. That's really important because the software really is the bridge to your customers in today's business world. DevOps has transformed so many companies. And here's a few examples of the transformation that has happened. 98% in the case of Gladstone, 98% reduction in coding errors. In the case of Pop Hutchison, from up to 4 weeks per deployment to just hours. And they have a pretty complex environment, lots of paper. So this thing is transforming businesses all over the place. But let's get into the DevOps model, okay? So we have concentric circles, and I want to talk about the automated DevOps pipeline first. That's in the center. It is the heart of a DevOps capability overall. It's absolutely the heart. So we're going to talk about that first. Your team needs the right environment in order to work. Okay, needs the right environment set up. Let me give you an analogy. Let's say that you were opening up a mechanics company, or in Texas, there is Lamb's Automotive and Firestone and Christian Brothers, and there's some other franchises, but essentially it's your mechanic and you go to get your oil changes or any type of maintenance or servicing on your vehicle. Let's say you're going to open up one of those. And so you buy a building in a great location, brand new building. You go and order several crates of perfectly beautiful Snap-on tools, and you have them delivered and they're ready outside. Then you go to the local auto mechanics school and you say, you talk to the dean of the school and say, I'm going to pay whatever it takes. I want your top 7% of graduates. You have a graduating class coming next month. I want your top 7%, and I'm gonna make them really good offers. I'm going to pay them what it takes. And so you hire the cream of the crop of this next graduating class. Really smart people. And then you take them into the new building and say, okay, team, Next week, we're opening up. The customers are going to come. Get ready. And then you walk away. They look completely wide-eyed at each other. They're looking at this brand new, beautiful building. They're looking at these crates of brand new Snap-on tools. I mean, you spared no expense. And they have no idea what to do because they were trained in a shop that was already set up for them. They weren't trained in order to set up the shop. And we work that way in the development world. All of the development curriculum is about working within an environment and not setting up the environment. Now, if you have someone really experienced who's been through many projects, then typically that person sets up an environment. But typically the people who work in a system or work in a assembly line factory are not the ones that design that factory. So as leaders of a team, we need to equip our developers with the right environment to be effective. And chances are you might have a developer who's kind of doing that job and creating an environment. But we're going to talk about holistically what all the things need to be in place. But foundation of tools and automation of environments and environment creation and builds and deployments through multiple layers of environments, at a minimum 3 levels of test automation. And so the automated DevOps pipeline is the foundation of an environment for your team to work and be able to go fast. But let's go through all of these layers. So the next layer that builds upon this are practices for the team. And when it comes to getting those set up, you need to establish some type of standards. One of those standards may be, we are going to adopt incremental design, and we're going to refactor as we go. That's a good standard to adopt. The solid principle, single responsibility principle, don't repeat yourself, YAGNI, those types of things. Good standards, not just coding standards, but hey, what patterns do we like generally? So the next one, TDD at the bottom, is test-driven development or whatever, actually executing those practices and having a rhythm of executing those. And then discipline is checking to make sure that those standards are still being executed. Okay. Then we have defect removal. This is so important because as you establish an assembly line process, you think of your swim lanes. If you're already using Kanban, an assembly line process, there can be problems at any one of those workstations. Okay. Problems don't just come in coding. Actually, Capers-Jones published research where the actual majority of defects or problems found in software originate in activities other than coding. And so as you establish your swim lanes of coming up with an idea, prioritizing that in the backlog, fleshing out the requirements and the details of that particular item or user story, making key technology decisions about that story with mockups and wireframes and what libraries you're going to use, specifying acceptance criteria or specifying test scenarios that are going to be automated with full system acceptance tests. If a mistaken analysis or a gap in analysis or a scenario that just flat out wasn't thought about, that's a problem. That's a defect. And if it flows on through, then it causes problems later down the road, as well as, a server can be misconfigured or a cloud environment can be set up improperly. Any problem is a defect. So yes, there are defects in coding, but there can be a defect that originates at any stage of work along the way. So defect detection is strategic here. And there are 3 quality control techniques that reliably get a team up to 95% defect removal before production. And that's shown in the research. And they are inspections, automated testing, and static analysis. And of course, when you go in with automated testing, it also must include some manual testing, but testing in general. Static analysis, there's plenty of options for static analysis to be integrated in the build process. Inspections, the most common types of inspections with DevOps is the pull request process that forces code to be developed on a feature branch and then peer reviewed into master, so that every change has an inspection process formally recorded. And then the test coverage. And then in order to monitor this and make sure that it's still going, we want to have defect reviews. Any defect that gets through, we want to look at why it got through and then go back to our defect detection practices and say, okay, what else do we need to bolster so this type of defect can't make it through later on? Then we have workflow. And this is the process that we use. This is the identifying which swim lanes to have on your board. This is establishing the workstations in your factory, in your software factory. What's our flow from the person that's coming up with the ideas for what to put in the software to the person or people that are watching the software as it's running in production as your customers are using it. And so the strategic element is defining what that process is, and tactically swim lane definition. And then as the whole process is established, we want to, and this is one of the key principles in DevOps, make all work visible. Not just software features, but anything that goes into shipping software, make all work visible. And we do that by making sure we have all of the swim lanes, because if we really do have all of the swim lanes, if we've accounted for every workstation in our factory, then there is a place for every type of work. If we don't have a place, then some of those symptoms would be work and tasks flowing through email or other systems. And some of the symptoms may be your developers are in a stand-up meeting the next day. What'd you work on? Well, I really couldn't work on this because I was doing this other thing. Well, that's a sign that there's some work that's not accounted for, that all of the work isn't visible. And then to keep it on track, we put in place workflow telemetry, and that is metrics on lead time, metrics on cycle time, and bottleneck identification. So we need to have metrics and ongoing telemetry as the work is flowing through, because imagine if there's a car manufacturing plant and the cars stop flowing, or the bumpers stop flowing, eventually the cars stop because you don't have enough bumpers. So it's a joy to work with teams that start out where product management or the stakeholders are asking, hey, what's taking so long? Why can't you guys speed up? And then totally flip that so that we squeeze out all the different bottlenecks, and the team actually starts waiting on product management and waiting on the stakeholders to make decisions, and the bottleneck moves upstream. And that's what typically happens. 20 years ago, there was a lot of bottleneck on procuring and buying servers, and then they had to be screwed into a rack, and then operating systems installed, and then provisioned properly, and then you could do software. And so sometimes people didn't deploy it twice a year, and then they sped up to once a quarter. And now we just think that's insane. We should deploy anytime we're ready. Well, progressively over the last couple of decades, and the bottleneck has moved from the tail end when we're actually putting software out on servers or computing environments, and the bottlenecks have moved upstream. We've continually shifted those bottlenecks left. And with DevOps, it reliably continues to shift the limitation of throughput up to the stakeholders, the rate at which they can make decisions about how to change the software, because the engineering is just going so quickly. And the vision ultimately is to be able to shift left all the way so that we can also make decisions quickly. All right, let's keep moving. So the next layer is blueprints. What are we building? Do we have visibility into what we're building? And so the strategic element is architecture definition. I love the 4+1 architectural blueprints pattern that came out in 1995. And it essentially establishes the layers of blueprints that you need in order to visualize a software system. If we're going to build something, then we have to be able to see what we're building. There's typically not any kind of trade that constructs or builds anything that I'm aware of that can operate without a drawing of some sort so that the whole team can visualize together what the outcome should be. Even if we're putting together a puzzle, my kids still need to see the top of the box so they can see what the picture is supposed to come out to be. And certainly, even if you're building a shed, you at least have a pencil drawing for the basic structure of the shed. So with software is so complex. We must have adequate visualization of what we're building. And in software, we have some common layers. The four most common layers for architectural blueprints for software are physical, logical, process, and development. The physical layer is, how is this thing going to run in a production environment? Am I going to have one virtual machine? Am I going to have one physical server in a data center? Am I going to use a physical server on VMware? Am I going to use a virtual server? Am I going to use a virtual server in Azure? Am I going to use Azure PaaS services? So that's physical. It's how do I structure the computing environments? Because the same application could probably be deployed in multiple different physical ways. That's the runtime environment. Okay. The logical is the separation of modules, even if it's in a common way these days, a web application on top of SQL Server. Okay, that web application could have many, many modules within it. And so the logical drawing is, what are the different pieces or parts of the web application and what's the interrelationship between them? If in Visual Studio, if you have multiple Visual Studio projects, then those could logically represent different things, and they would have directionality of dependency. Okay, and then processes for typical transactions. How does data flow through your system? What is the process from what a user does to going through the system to some type of outcome? And then to execute this, we need to keep them up to date. The development layer is what development tools or development configuration is necessary to develop against the system or maintain the system or grow the system. We need to keep those architectural blueprints up to date, because at some time we're going to say, you know what, let's add another offline job. And this offline job is going to have some type of responsibility. We need to update the architectural blueprints as we make a change, because when someone comes in, even with sprint planning, you need to be able to look at, hey, what is the current shape of the system now? And what is the intended shape of the system after the sprint or after this next release? Okay. And then as with any type of building, from a leadership perspective, we need to do periodic walkthroughs and actually look at the plans, look at the blueprints, these pictures, and then walk through the code and walk through the modules. And it could be something like, hey, I'm looking at these plans. I see a box for the emailing module. Hey, can you show that to me? You need to do a periodic walkthrough to validate that. Okay. Then cloud operations. Now, if you're not in the cloud now, just fast forward some number of years, and either you're going to go to the cloud or the cloud's going to come to you. With Azure Stack, it's more and more possible to actually make even local data centers run the Azure operating system. So the server has transformed even beyond the virtual server to more granular operating units, PaaS services, containers, things like that. So the strategic element is centralized logging. We need every piece of software to be pushing logging information to the same place, or we need an aggregation mechanism if it's putting into various log files. And we need to keep up to date monitoring and alerts, and tune the alerts so that when something out of the ordinary happens, we get some type of signal that happened. And then we need an incident management capability in order to track what is happening, what bad things or what alarms have gone off, and the knowledge base is part of that. When we have that entire DevOps setup, then we're able to have a really streamlined cycle. We plan, then we code, we integrate, we package, we release, we operate, we learn, and then we do it again. It enables us to have a single piece flow capability. Whereas we wanted to make one change, great. Let's plan the change, code the change, integrate the change, package the change, release the change, then let's operate it and let's watch it. And let's learn if our hypothesis about it being a good change was in fact good, because when we change things, there's some research that shows we have an even distribution. We have a hypothesis. Hey, let's add this feature. Let's make this change because it'll be a good thing. 33% of the time we were right, and it helps things. 33% of the time it has no effect, and 33% of the time it actually ended up being harmful. And so when we prioritize things in a backlog, those are just hypotheses. We don't actually know that it was a good idea until we operate it, watch it, collect telemetry about how our customers are using it, and learn which of the three, and then continually hone and continue to get better. Okay. So this model holistically is our DevOps model, and this is what you need. This is what you need to think about when putting together your DevOps process for your team. Account for everything that I've mentioned here in some way. Now, you've noticed some alignment here. On the top left, we have sort of a wing going up through the layers of our onion here, and those are strategic. Those represent the strategy in each of the areas. A strategy for what engineering practices we're going to be using, a strategy for defect removal, a strategy for the workflow that's going to yield productivity, a strategy for our architectural blueprints, and a strategy for operating the system. And then at the bottom, you see execution. These are what we're going to do in order to execute our strategy on an ongoing basis and keep things on track. And then on the top right is measurement. These are what we're going to do to see to what effect we are effectively executing, so that we can make sure that things continue to go well. Okay, so those are the different wings. Now, we'd love to help you out implementing this. If you need help, or even just advice, or if you want some free advice, just call my phone. It's listed here at the end of the slides. We have two practices here at ClearMeasure. One is we enable your team to be self-sufficient by accounting for and helping you implement all of what's necessary for a DevOps capability. And it's run by, this is your team. We are enabling you to be self-sufficient and world-class. If you have a company where you've decided not to have software developers on staff, we can build a team dedicated for you and operate it for you. So those are the two different practices that we have here at ClearMeasure. Next steps, we can define a project, do an assessment, review your software or environment, or put together a modernization roadmap, whatever would be helpful for you. And I told you we were going to be efficient. This is about strategy. You guys are busy. You guys have lots of things to do. So I think we've been able to carve off 30 minutes here. We've gotten through all the content. And so thank you so much for being with me today. This is my contact information. Reach out to me directly and let's chat. And I appreciate you being with me. Thanks so much. And I'm going to hang out here for any questions with the chat. Put the questions in the Q&A window, and I'll hang out a little bit and answer any questions that you guys may have. All right, so we have a question. Are all of the layers necessary in order to do DevOps? And that's a really good question. And my answer is yes. Now, you can be really thin on those, or you can go heavy. But here's the thing. You have to decide what engineering practices that you're going to adopt. And if you don't write them down in a document, you're still going to have a conversation, and you're still going to have some engineering practices. So that always happens. It's just, are you thinking about it intentionally, or is it more ad hoc? Defect removal. Defects are going to happen, and they can either happen in an uncontrolled fashion or a controlled fashion. And workflow. You will have a workflow. It's just a matter of, do you think intentionally about it, or does it just happen? Blueprints. Everybody who is building something has an image of what they're building. The question is, does everyone have the same image? And if it's not drawn anywhere, even if it's just a whiteboard with a smartphone picture, That's enough in some cases, but everybody has a picture in their head. The question is, how do you validate if everybody's mental picture is actually the same so that you can align everybody? And then cloud operations. Even if you're in an on-premise data center, you have to operate the software. And so you at least have to have the capability to observe how the software is running. So you're monitoring it. And then you need the ability to respond to anything that happens, called incidents. So yes, you do need all these layers. And what this model does is identify the strategic aspects to each layer, the execution aspects, and then the measurement aspects, so that you can have a really streamlined cycle and you can just spin that cycle and have a quicker and quicker cycle time. So, all right, another question. Where can I get your slides you're presenting with? Very interested in everything that you had to say. Hey, good question, Joseph. Send me an email. It's on the screen right here, and I'd be happy to share this with you. So yeah, easy enough. And yes, this is my phone number. If you were to call me right now, this would ring. So email me, call me, text me, or follow me on Twitter with any follow-ups whatsoever. So I think those were the questions. So thanks so much for being with me. I know your time is really valuable, and I hope you have a Merry Christmas, Happy New Year, and keep in tune for future webinars, and give me a call if you have any questions, and we'll have a chat. So have a great day.